This video, I'm going to show you how to work a word problem that has a rate of the current in it as a question. Inya rode 16 miles down a river in 2 hours, but the return trip took her 4 hours. Find the rate that Inya rose in still water and the rate of the current. So I'm going to start off with my unknowns. What are they asking? They're asking for the rate Inya rose in still water, so that's going to be one unknown, and the rate of the current, that will be the other. So that's what I did. X equals the rate Inya rose in still water, and Y the rate of the current. Now this is a distance equals rate times time problem, so I'm going to make a chart. And I'm going to put the formula as distance equals rate times time, so I'm going to put the distance over always the one that's alone on the last column, and then R and T, doesn't matter where they go. And I'm going to try to fill out just the first two columns. So I'm going to leave the 16 miles alone because that's a distance and I don't want to fill out that last column. So the 2 hours. We know that Inya rose down the river in 2 hours. So I'm going to write the word down the river in 2 hours. Okay, the return trip took 4 hours. That's return trip. So by the way, it's going to be up the river, or you can call it the return trip. And now the rates. In all the other distance equals rate times word problems that we've done, besides the current or the with the air and against the air type of problems as well, you usually put X and Y. But when you ever have a current or a wind problem, you cannot do that, because if you notice, if I put X for the down here, that would be the unknown would be the rate going down the river. And they're not asking for the rate going down the river. They're asking for two totally different things. They're asking for the rate in still water and the rate of the current. So to show this, I'm going to draw a little picture. So here's my river going down. Here's my boat. There it is. And I'm going down the current pretty steeply, actually. Now, if I was in still water, not going downhill, I would row X. But the current is helping me go along. So to get the rate downstream, it would be what she did in still water plus the rate of the current. Now this makes sense. Say you're going, for instance, at 30 miles per hour and the current is 2. I realize I'm just making these numbers up. But if you notice that 30 miles per hour were what you would row in still water, and then the current is 2, so that would be helping you along. You would be going at 32. You'd be going a little bit faster than you would be in still water. And if you're going on your return trip, you would be going up. So you would take the rate in still water and you would subtract that current. Now we can get these distances by multiplying, and don't forget to use distributive property here, so I'll put it in parentheses to show you that we have to multiply those whole things. And now we are done with the chart. So now we're going to look for two equations. The first equation I'm going to use, I know the distance down is 16 miles. So here's an expression for the distance down. So if I take the 2x plus 2y, that would equal 16. Multiplying those out. And a similar note, the return trip, even though they don't give us the number again, is also 16 miles because it's the same distance. So the second equation is 4x minus 4y is also 16. So those are the two equations I'm going to work with. Let me just rewrite them so we have more space. And I'm going to solve this. Now I want to solve by either elimination or substitution. So I'm going to choose elimination. To choose elimination, I'm going to eliminate y by manipulating this so that way when you add these together, the y's go away. So I notice if I multiply both sides by 2, I'm choosing 2 because then this would make this a 4, and then we have a negative 4y, which would go away. If you multiply the left side by 2, you need to multiply the right side by 2. So let's go ahead and do that. what we're going to do is use the Schroeder property and just multiply 2 by everything. So the first equation would be 2x plus, so no it wouldn't, it would be 4x. 4x plus 4y equals 32, multiplying everything by 2. The second equation does not change, so I'll just rewrite that. And I notice when I add these together, the y's go away. So I just eliminated the y, and I get 8x equals 48. So x equals 6. To find the y, I need to plug this into any one of the equations. I'll use this first equation, either one. The first one looks nice and easy, and if I plug in x is 6, what do I get? 2 times 6, and that becomes a 12. We're going to subtract 12 from both sides and get 2y equals 4. Divide both sides by 2, and you get a 2. So we just found out that the rate of Inya rose in still water is x, which is 6 miles per hour, since we're in miles an hour. And the rate of the current is 2 miles per hour. So downstream, she actually was going 8 miles per hour, where upstream, she was only going 4. So just rewriting what I just said, that is the answer to our word problem. I hope that helps.